We've been talking about measuring distances. Now we're going to talk about measuring the mass of objects in space, the Milky Way in particular. And this is much, much easier than measuring distance. As a matter of fact, all it takes is high school physics, Kepler's laws. You basically need to know two things. You need to know how far a star or some object is away from the center of the galaxy, and you need to know how fast it's moving. And then you can easily calculate the mass that's slinging it around. And based on that physics, we know that our Milky Way galaxy weighs, or has a mass of, 600 billion solar masses, 600 billion times the mass of our sun. Pretty hard to contemplate. Now, that doesn't mean there are 600 billion stars. As a matter of fact, the estimates range from about 100 to 200 billion stars. This 600 is the total mass, including things like black holes and dark matter and so forth. Anyway, we live in the disk, of course, and in the disk and bulge combined, there's about 100 billion solar masses closer to the center than us, and about 100 billion farther away from the center of the galaxy than us, which leaves, of course, a missing 400 billion solar masses, which is almost embarrassing that we don't know what that 400 billion is. That's in the halo area of our galaxy. As to how much 100 billion is, 200 billion, if we just talk about the number of stars in our galaxy, imagine a handful of birdseed. How many seeds would be in your hand? Just a big pile of birdseed. And now start sprinkling it over a football field. And you could cover an entire football field with that birdseed, and that represents the number of stars in our galaxy. Oh, when I say cover the football field, I actually mean cover the football field 4 feet deep. Imagine wading through 100 yards of birdseed, okay, up to your chest, 4 feet high. It's just insane. And that represents the number of stars in our galaxy alone. Not in the universe, just in our Milky Way galaxy. So hard to contemplate. Anyway, what is all this missing matter? Well, there are two camps, two trains of thought here. The first one, and it's kind of humorous here, the idea is that there are a bunch of very small particles, subatomic particles, of which we are not aware yet, and they make up the missing mass. Kind of a funny name for them. They call them WIMPs. Stands for Weakly Interacting Massive Particles. Weakly interacting. They can fly right through most matter. But they do have mass. Weakly interacting massive particles, they do have some tiny bit of mass. And if there's a whole sea of these out there, then they would account for the missing matter. So maybe this is dark matter. We've had one WIMP so far that we've talked about a few times, neutrinos. So a neutrino is your example here of a WIMP. But there may be other of these subatomic particles we haven't yet discovered. For example, there's one called a neutralino that they're trying to discover to see if it actually exists or not, to help explain dark matter. Well, some scientists don't like this idea at all. They think that there are larger scale objects out there that we can't see, and they account for the missing mass. So to kind of make fun of the WIMPs, they call their theory the MACHOs. This stands for Massive Compact Halo Objects. So objects in the halo of our galaxy that are massive, but they're so small and so dark that we can't see them out in the halo. For example, black holes. Now, astronomers believe there are probably millions of black holes in our galaxy alone. So that probably is some of the missing matter, but there wouldn't be enough just of black holes to account for 400 billion. Well, there may be other things out there as well that we can't see. Certainly, there are going to be a lot of brown dwarfs in our galaxy. And these are stars that never quite ignited, or they fizzled out. They didn't quite have the mass. And they're going to look a lot like a very large Jupiter, probably. But they're not giving off light, so we're not going to see them. And sure, there are probably tens of billions of these in our galaxy, and that would account for some of the missing matter, along with, normal stars like red dwarfs that are just hard to see. So that may be a lot of it. Personally, I think that dark matter is probably all of the above. We may find some more of these exotic particles, and we may find that there's a lot of actual massive objects out there that we just can't see. Anyway, this is a quick little video I'm going to end this part showing a picture that was released a couple of years ago. They got a lot of attention. A lot of news sources actually really messed this up. They said this was the first picture of dark matter. Well, not quite. You can't take a picture of dark matter. What you're looking at is more like what I would call a map of dark matter. The pink areas kind of represent matter that we can see. And then the blue areas represent where there is dark matter. Now, that's hugely important because it shows that dark matter really is there. I mean, even a few years ago, there was a thought maybe we're just messing up. Maybe our physics is wrong and there's not actually dark matter. But it looks like at this point that dark matter really does exist. We still don't know if it's the WIMPs or the machos or both, but we can plot out where it is based on gravity. Dark matter has gravity and it's pulling on things around it, so that astronomers can carefully map out where the dark matter is now, which is, again, a pretty big breakthrough. And this is just one of those areas, it's one of the great mysteries still to be solved in astronomy. Thanks for listening.